We've learned a lot about how muscles are stimulated in living organisms, but what happens when they die? How does the cessation of ATP production affect an organism's ability to experience post-mortem muscle contractions? In this video, we examine chemical and electrical stimulation of deceased organisms and look at some surprising cultural practices associated with the phenomenon.
This video is posted on YouTube in July of this year and currently has 353,000 views. It shows a dish where an octopus is doused in soy sauce and its limbs move so it appears to be dancing. This dish is called adori-dan and is a delicacy in Japan. Because of its impact, there has been a great deal of reaction on the internet. Some bloggers question the ethics of this demonstration. They believe that this octopus is alive and go so far as asking that the proprietors of this restaurant be prosecuted for animal cruelty. These bloggers would really be appalled by this scene from the Korean film Old Boy. Is the octopus in the YouTube video really alive? Octopuses have both peripheral and central nervous systems. The octopus in the video has had its head cut off, so it is missing its central nervous system. However, it relies a lot on its peripheral nervous system for motor control, which is one of the reasons why it is still able to move its legs. Octopuses have a basic motor program for arm extension that is embedded within the neuromuscular system of the arm and is independent from the nervous system of the rest of its body.
There are a number of possible chemical indices of freshness, including presence of AEC, hypoxanthine, and xanthine in tissues. A study on the common squid Totodara specificus found that the ratio of hypoxanthine to AMP was the best chemical indicator of freshness, dropping linearly after a squid is killed, while AEC drops rapidly and then flatlines after a single day. It would be interesting to see which of these chemical indicators would be most useful in predicting an organism's ability to experience chemical post-mortem muscle stimulation, but unfortunately, no papers were available on the subject. The ability of an organism to experience post-mortem muscle contractions is directly related to its available adenylate energy charge, abbreviated AEC. It is a ratio that describes the amount of ATP relative to levels of ADP and AMP. The availability of ATP and related compounds varies among octopus tissue, including abalone tissues, abductor muscle, foot muscle, mantle, and viscera. A study by Yokoyama et al. Found that the total content of ATP and related compounds in mantle muscle to be about 9 micrograms per mole, as opposed to 5 micrograms per mole in arm and fin muscle.
We believe that the high salt component of the soy sauce is what causes the octopus muscles to contract. In a study of 23 different soy sauces from around the world, the amounts of sodium range from 18 to 41%.
Action potential occurs in the neural networks and is divided into 3 primary stages. During the resting potential, cells have a net negative charge of 70 millivolts compared to its outside environment due to the high concentration of sodium outside the cells. When stimulated, small amounts of sodium seep into the cell, opening the sodium channels. This allows the bulk of the sodium ions to flow into the cell, depolarizing it to around positive 30 millivolts. At this point, sodium channels close and potassium channels open, allowing potassium ions to rush to the extracellular environment, repolarizing the cell back to its resting potential. Muscle contraction occurs as a result of the action potentials. Muscle fibers are composed of actin and myosin filaments. ATP releases the myosin cross bridge from its previous actin binding site. It hydrolyzes to ADP and an inorganic phosphate group as the cross bridge hooks onto a new binding site. The release of ADP and phosphate induces a power stroke, resulting in the contraction of muscle fibers.
Moving dead body parts is not a new thing. In fact, it was a form of sadistic entertainment in the 19th century. In one demonstration, the body of a convicted murderer who was recently hung was connected to a battery by a physics professor. First, the professor shocked the corpse's face, causing the eyes to open up. Then he caused the body's fists and arms to move. Sadistic demonstrations like this may have moved author Mary Shelley to write Frankenstein.
With electrical stimulation of a deceased organism, availability of ATP becomes less important compared to the integrity of structural tissue. Cadavers retain moderate to high levels of muscle excitability until the onset of rigor mortis. A study on Atlantic salmon found that out of experimental groups of the fish that were either electrically stimulated, physically stressed, or neither, the electrically stimulated fish experienced the fastest drop in pH and corresponding onset of rigor mortis 2 to 4 hours after they were killed. The process also accelerated the eventual softening of the flesh post-mortem. Interestingly, as these are important steps to the conversion of muscle to meat, the food industry widely uses post-mortem electrical stimulation to improve the tenderness of beef, lamb, turkey, and veal. Electrical stimulation helps prevent cold shortening and improves meat tenderness, color, and appearance. It also hastens the development of bright red muscle color, muscle firmness, and marbling.
The demonstration you might have seen in the 1900s.